So in this first video, we're going to be looking at section 5.2, and we'll be discussing inverse functions. And before we get started with inverse functions, it'd probably be a good idea to lay out some goals for us as we work through these. So the goals we're going to try and meet by the end of this series of videos is we're going to want to be able to first identify what a one-to-one function is. And in doing so, we will then be able to achieve our next goal, identifying inverse functions, as those two we'll see are connected. And after we can identify an inverse function, we understand what inverse processes are, we'll then be able to focus our attention on trying to find inverse functions for some given function of x that we may have. And with a function of x and its inverse in mind, we're then going to look at the connections between them and how they relate both analytically and graphically as we work through these. So as we get started in looking into one-to-one functions first, it's probably a good idea to go back and remember our definition of a function from the beginning of the semester. So we started off the semester by defining a function as a relation between two variables where each element of the domain, so namely the x's, will be matched to exactly one element of the range. So if you put in a particular x value, it's only going to go to one specific y value if we're dealing with an xy function. We could take a look at this by looking at a quick sketch of a graph and see why that we could run into trouble if this isn't the case. So let's say we've got an x and y axis, and we'll just sketch a little curve here, maybe something like this. Kind of looks like a sideways parabola. Well, it turns out that this curve is not a function, and we can see that it violates the definition if we were to pick some point on the x-axis, let's say 3, and we were to look at where 3 falls on our curve. Well, if we go up to our curve, we see that when x is equal to 3, there are two different y values. So if we were to plug 3 into some formula for this function, it would be going to two different places or two different values on our range. So this would not be a function. And in general, we can determine if we do have a function by saying that the graph will pass the vertical line test. So the vertical line test. And as we can see here, this example does not, which is why we can determine that this is not a function. So with this idea of how we define a function, now we're going to go ahead and define what is meant by a one-to-one function. So as the name might imply, it's a specific type of function, and we can see in the definition that a one-to-one function is a function, first and foremost, so it's got to pass the vertical line test, where each element of the range is related to only one element of the domain. So it's sort of the opposite there. So this is telling us that now not only does each x go to only one y because it's a function, but now each y is going to only go to one x. So we have this exclusivity, or sort of like a monogamous relationship between our x's and y's. Each x will only go to one y, and each y will only go to one x. We could see how we might run into trouble if we were to look at a graph like this. Let's say I put a curve, and this is our x and our y-axis. And let's say we've got something that looks like this. So kind of a polynomial looking type function. Well, let's take a look at this. First of all, is this a function? Well, if we look across the domain, we don't have any problems with the vertical line test. So we could look at this and say, well, yes, this is a function, because it passes the vertical line test. Now, is this a one-to-one function? Well, let's pick a y value. Let's say we went here on this. Let's say this is y equals 1. So for that y value, how many x coordinates are associated with it? Well, let's see. Over here, when y is equal to 1, there's an x value. If we keep going, there's another x value associated with that y, and if we keep going, there's even another one. So for y equals 1, there are 3 different x values associated with it. So that violates our definition in that that element of the range is related to multiple elements of this domain. So if we were to see if this is, if we were to ask if this is one-to-one, we would say no. Now, we have a similar vertical or a similar test to this in terms of the graph to determine if we've got a one-to-one function, except here we would say that in order for a function to be one-to-one, it has to pass a horizontal line test. And it's a rather easy conclusion to draw if we do have access to the graph of our function. So that's how we define a one-to-one function. So the following could be considered equivalent statements here if we're looking at some function f. So we're going to say that the following statements are equivalent for some function f. So let's say we've got some function f. Well, if I were to tell you that f is one-to-one, and oftentimes we're going to use the notation 1-1 to denote we're talking about a one-to-one function. So if I told you that f is one-to-one, that would be the exact same thing as me telling you that the graph of f passes the horizontal line test. I'm just going to abbreviate this, the horizontal line test. So if you have either one of those, they're telling us the same thing. Now this is where one-to-one comes into play with inverse functions. If we know that our function is one-to-one, meaning we know that the graph passes the horizontal line test, the following is also true. We say that f is invertible, meaning that we can calculate an inverse function for this. So this is going to be a particularly important to us as we move on to the next video. Now before we move on to thinking about inverse functions, I'd like you all to try just a quick example or two before we move on to the next video. Just try these on your own. So try these. So determine if the following are one-to-one functions. So let's start with, let's say this first one, we'll go with something like 4 minus x squared. And for our second function, let's try, and actually, just so we've got let's make this a little more clear, let's call this y is equal to 4 minus x squared. And for our second one, go ahead and try, let's say y is equal to 3x cubed plus 1. So probably the easiest way to do this is just go ahead, use your, you could use your calculators and graph these and determine whether we're dealing with a one-to-one function. And we'll go over the answers for these in the next video.